Now let's talk a little about matrices, lesson 3.6. So this here is an example of a matrix. A matrix is a rectangular group of numbers used to represent a system of equations. So this particular matrix would represent two equations. Now, we name a matrix by the number of rows and the number of columns. So this one has 2 rows and 3 columns. So we call this a 2 by 3 matrix. If we want to talk about a particular term, for example, term A1, 2, that would be the term in the first row and the second column. So term A1, 2 would be 2 in this case. Term A2, 3 would be second row, third column, 3. All right. If I wanted to rewrite a system of equations as a matrix, I would set it up. My x's would go here, my y terms here, z terms here, and the equal terms here. So the first one is 4x, but we're just going to use the coefficient in the front. Second one is negative y, so we just use that coefficient, negative 1. Z is 2z, we just use the coefficient, and it equals 1. There is no x term for the second equation, so we'll say 0. There's a 5 for the z, a 1 for the y, and 20 for the equals. Then we have 2x, 1y, 0z, and a 7. Now we can use this to solve systems of equations, so we don't have to do all of that complicated elimination and substitution stuff, by moving around the matrix to make it look like this. Either 1, 0a, 0, 1b, where the diagonal is 1s. This means x equals a and y equals b. Or if there are 3 variables, this means x equals a, y equals b, and z equals c. You always try to set it up with a diagonal and then all of the other terms as zeros. Here are some row operations. You can at any time switch any rows. You can multiply one row by a constant. You can add one row to another row. And you can combine any of these steps in any order. So let's take a look and see how we're going to do that. When we're solving systems of equations using a matrix, the first thing to do is write the system as a matrix. So we have 9, negative 2, and 5. 3, 7, and 17. The important thing is to make sure that your variables line up, and your answer is the last column. So 9x, 3x, 9, and 3 are in the same column. First thing you want to do is you want to look and see how can I make it so that 9 and 7 become 1s, and then my other numbers become 0. I see first off, if I multiplied my bottom row by a negative 3, my 9 and my negative 9 would end up canceling out. So that's the first thing I'm going to go ahead and do. I'll multiply my bottom row by a negative 3. When I do that, I will get a negative 3. I will get negative 9 minus 21 minus 51. And then I'll add that to the top row. Doing that, I get 0, negative 23, and negative 46. I then will take this, and since it has a 0 in front, I'm going to want that to be my new bottom row. So I still have 9, negative 2, 5. But now in my bottom row I have 0, negative 23, and negative 46. Next I look and I see that by dividing by 23, I can get that middle number to turn into a 1. So negative 23 divided by negative 23 is going to be 1. And negative 46 divided by negative 23 is going to be 2. So I can change those right there. Next, I need to try to get my 9s to get out of the way, or get my negative 2 to cancel out to 0. So I know that if I took my bottom row and I multiplied it by 2, I could add it to that top row. So I would have 0 times 2 is 0, 1 times 2 is 2, and 2 times 2 is 4. And then I have my 9, my negative 2, and my 5. I can add those straight down. I will get 9, 0, and 9. So this will be my new top row, 9, 0, 9, and I'll keep my bottom row 0, 1, 2. Now I see that I can divide my top row by 9, and when I do that, I will get 1, 0, and 1. My bottom row will stay 0, 1, and 2. Now what this means is that my x equals 1 and my y equals 2. I'll write my answer as an ordered pair, 1, 2. You can also solve 3x4 matrices using these methods, but they can be just as tedious as doing elimination and substitution. There's a way to do it with your graphing calculator, but I will show you that way in class. Our joke of the day: why didn't the toilet paper cross the road? Because it got stuck in a crack.